Harshita, at your place, which chapter started?
Sir, we completed mechanical properties of solid.
No, fluid is not started so far.
No, sir.
Okay. Have you heard about friction? Have you heard about word friction?
Yes, sir.
Yes, sir.
What is friction?
Sir, the opposing force acted on a moving body.
That means not only moving, whenever there is attempt made to produce relative motion or there is relative motion between two bodies in contact, then force which opposes the motion is called as friction. Correct ना?
फोन की बहुत जरूरत है यार.
So body may be at rest or there is relative motion. This relative motion is opposed. That opposing force is called as actually friction. Correct ना?
Yes, sir.
Okay. So similarly, in liquid also there is chance there will be opposition between the liquid molecules. Suppose this is surface.
Yes.
I drop or spray the water here. Will the water keep on moving continuously and it will reach from
मम्मा
Mumbai to
मम्मा
Cobra?
हेडफोन की जरूरत है यार, नहीं जम रहा है.
Hello?
Yes, sir.
Will this liquid water will travel from Mumbai to Goa if I spray it on the surface, or it will stop after
No,
that?
sir.
It will stop, na?
Depending upon the surface, I mean, if the surface is inclined, you spray the water, it
Then
will
it will
move
go.
down a bit. And if it is a flat surface, it will stay intact on its position.
No, I'm talking about same surface. I drop water first, then kerosene, then mercury, then paint. All will cover same distance.
No.
नो सर.
So depending upon their nature, some will cover larger distance, some will cover shorter, some will cover still shorter, some will just stick as soon as it is falling. So somebody is opposing, no? That somebody is called as viscous force. Like we have friction, here it is called which force? Viscous force.
Viscous force.
And property which is opposing relative motion between two adjacent layer of liquid is called as viscosity. देखो किसको किसको ना ब्लड प्रेशर का प्रॉब्लम होता है तो डॉक्टर उनको मेडिसिन देता है which makes the blood thinner. Thinner means more viscous
Yes,
or
sir.
less viscous?
Sir, less viscous.
Less viscous. That means it can move smoothly, ना?
Yes, sir.
क्योंकि उनका ब्लड प्रेशर हाई है अगर ब्लड पहले से ही थिक होगा तो ये ब्लड भी प्रेशर बहुत देगा तो चांसेस आर दैट दे विल गेट फेटल एक्सीडेंट और दे मे गेट stroke. So doctor gives that blood pressure medicine. Its job is nothing but to reduce the viscosity between the two blood layers. So what is viscosity again? The property by virtue of which relative motion between adjacent layers of liquid is opposed is called viscosity. The force of opposition is called viscous force or viscous drag. Again, I'm repeating. The property by virtue of which relative motion between adjacent layers of liquid is opposed is called as viscosity. The force opposing opposing is called as viscous force or viscous drag. Dragging means pulling. So viscous force or viscous drag. So what is viscosity? The property by virtue of which relative motion between adjacent layer of liquid is opposed is called as viscosity. The force opposing is called as, or opposing force is called as viscous force or viscous drag. Followed meaning of viscosity and viscous force?
Yes, sir.
Because force is involved, therefore it is called mechanical property. Right, viscosity definition.
Done, sir.
Okay. You all have written, na?
Yes, sir.
One minute, one. Next heading, types of flow of liquid. Types of flow of liquid. When something is flowing, is it necessary एक तरीका ही चलते जाएगा? ऐसे सेम कांस्टेंट स्पीड से. ड्यूरिंग कोरोना इन रेनी सीजन एक ऐसा न्यूज है चक्री वादळ आने वाला है. सुना आपने चक्री वादळ?
Yes, sir.
So that
Yes, sir.
cyclone, if it comes, Chakri Vadad or Katrina, these are cyclone names. Then the water in the sea, it will move smoothly or it will become rough.
It will become rough.
अब कौन सा चक्रवादळ रफ करेगा वो डिपेंड करता है उसका वेलोसिटी पे ना.
Yes, sir.
तो ये लिक्विड अगर जा रहा है, मैं धीरे धीरे स्पीड बढ़ाऊं उसका, तो एक चांस है ना कि उसका दिमाग खराब हो जाएगा और चक्रवादळ के जरा किधर भी जाएगा. So there are two types of flow. One is called streamline flow of liquid. Streamline flow. हर एक लिक्विड का क्रिटिकल वेलोसिटी और वेलोसिटी इज डिफरेंट टू विथस्टैंड द प्रेशर. सपोज मैंने आपको बोला कल एक चैप्टर का टेस्ट, आपको कोई तकलीफ नहीं, बिकॉज आपका फ्लो रेगुलर है, रेगुलरली यू आर स्टडिंग. यू सेड सर आई डोंट हैव एनी प्रॉब्लम बिकॉज रेगुलरली आई एम स्टडिंग. यू कीप वन चैप्टर. 2 चैप्टर रखा, still he said no sir I don't have problem, I can still manage because regularly I am studying. जैसे ही 3 रखा, आवाज है सर वैताग ले आता बस, कभी 1 कभी 2 कभी 3 बोलते. दिमाग खराब हो गया मेरा. दिमाग खराब हो गया तो दिमाग में मुंबई के लैंग्वेज बोलते हैं दिमाग का दही हो रहा है ना, मतलब दिमाग में
यस सर।
टर्बुलेंस हो रहा है. तो
Yes,
मैं
sir.
2 चैप्टर तक संभाल सका रेगुलरिटी से, तीसरा आया तो मेरे दिमाग में टर्बुलेंट हो गया. ये हर एक के दिमाग में टर्बुलेंट होगा क्या 2 3 चैप्टर से? कोई बोलेगा
नो
नहीं
सर।
सर आपने जितना पढ़ा है ना सब रख दो, मुझे टर्बुलेंस नहीं होएगा. तो उसका कैपेबिलिटी अलग है ना.
Yes, sir.
तो वैसे हर एक लिक्विड का फ्लो करने का कैपेबिलिटी अलग है टू अपोज द मोशन. वो जो स्पीड से जा रहा है हर एक का अपना एक क्रिटिकल वैल्यू होता है. देखो अभी एक पर्सन है जिसका रोज का खर्चा 500 है, संभाल लेता है वो क्योंकि उसका अर्निंग है 1000. लेकिन कोई ऐसा होएगा ना जो 50 रुपीज अर्निंग करता है तो उसको 500 तो टर्बुलेंस देगा ना, बेचारा सुसाइड कर लेगा.
Yes, sir.
तो दिस क्रिटिकल किसका कितना है मुझे मालूम नहीं, हर एक का अलग अलग रहता है. सो व्हेन द लिक्विड फ्लोस विथ वेलोसिटी लेस देन सर्टेन क्रिटिकल मतलब जिसपे वो अभी किधर भी जा सकता है, उसको हम लोग क्या बोलते हैं, स्ट्रीमलाइन फ्लो ऑफ. हर एक लिक्विड के लिए अलग अलग रहता है. नहीं समझ में आया लगता है.
समझा।
कॉन्सेप्ट समझ गया ना आपको. सपोज बहुत लिक्विड है,
यस सर।
कितने टाइप के लिक्विड आपको मालूम है? एक्चुअली बेसिकली 3 ही लिक्विड होता है. एक जो पूरे दीवार के कंटेनर को वेट करता है, दूसरा जो कंटेनर को वेट नहीं करता है, मरकुरी अगर ऊपर से नीचे पास करेंगे ना दीवार को टच नहीं करता है, वो सीधा आर पार हो जाता है और नीचे ड्रॉपलेट ड्रॉपलेट हो जाता है. देखा है आपने ऐसा? थर्मोमीटर हैव यू एवर ब्रोकन?
No, sir.
So if you break the thermometer, you'll feel that mercury will come out and it will be split in the form of droplet, droplet, droplet. Have you done volumetric analysis? Schools.
No, sir.
तो कॉलेज में आपको एक आएगा वॉल्यूमेट्रिक एनालिसिस, that is called titration point, where I think formula comes N1 V1 is N2 V2. बचपन में किया था, याद नहीं आ रहा है. So if I put in burette different liquid, some liquid will wet the wall of container maximum. केरोसिन आर पार किया तो थोड़ा थोड़ा होएगा, ग्लिसरीन और भी कम हो जाएगा. ऐसे अलग अलग टाइप का लिक्विड है तो उसका अलग अलग क्रिटिकल कंडीशंस होंगे. So I'm saying like this now. The liquid, when the velocity of liquid is less than certain critical value. हर एक का क्रिटिकल सेम है क्या? हर एक लिक्विड का
No,
क्रिटिकल
sir.
तो हर एक का अलग अलग है. When the velocity of liquid is less than certain critical value, then the flow is called as streamline flow or steady flow or laminar flow. Not followed. मतलब ये पाइप है, इसके अंदर ये लिक्विड फ्लो.
Followed, sir.
यस, ये लेयर में एक सरीका आगे आगे शिफ्ट होते जा रहा है, इसको बोलते हैं स्ट्रीमलाइन. लेकिन इधर उधर किधर भी जा रहा है तो हम क्या बोलेंगे, टर्बुलेंट. So streamline flow, steady flow or laminar flow, meaning lamina means this plane. So this entire planar body drifts, drifts, drifts with constant speed. Then it is called streamline flow. So they can ask you, what is streamline flow? It is flow with velocity less than critical, where all the layer moves in same direction and does not changes its path. Okay, streamline flow clear?
यस सर।
So
Yes, sir.
what will be the turbulent flow? Flow when velocity becomes greater than critical, it becomes turbulent. तो ये इधर से निकलते समय फाउंटेन जैसा हो जाएगा, किधर भी जाएगा. Right. There are,
यस सर।
write down, there are 2 types of there are two types of flow of liquid. First, streamline flow. Streamline flow. The flow of liquid with velocity less than certain critical velocity. The flow of fluid with velocity less than certain critical velocity is called as streamline flow. It's called as streamline flow. Next, turbulent flow. Turbulent flow. The flow of fluid with velocity greater than certain critical velocity is called as turbulent flow. It's called as turbulent flow. If you complete, please tell.
Done, sir.
Velocity gradient. Velocity gradient. What is meaning of gradient? Its actual meaning is slope, and mathematically
Yes, sir.
this is gradient ना, ऐसा ऐसा है ना, ये नीचे नीचे आ रहा है, उसको gradient बोलते हैं, स्लोप भी बोलते हैं उसको हम लोग. अभी ये वेलोसिटी ग्रेडियंट मतलब इनडायरेक्टली वेलोसिटी और डिस्टेंस के बीच का रिलेशन. जब भी ग्रेडियंट आया ना, इट इज विथ रिस्पेक्ट टू डिस्टेंस, ऐसे याद रखना. और रेट अगर किसी ने बोला रेट ऑफ, तो विथ रिस्पेक्ट टू टाइम होता है जनरली, अनलेस अनटिल टोल्ड. सो इफ दिस आर डिफरेंट layers of liquid flowing, if liquid enters from one end of the pipe and comes out from other end, here I place one bucket. Which layer will come first? First, second, third, fourth, fifth, 6 लेयर बताया. तो कौन सा ये बकेट में जल्दी गिरेगा?
Sir, the first layer will fall a bit early.
No, all the layer comes together ना. ऐसा कभी आपने देखा है कि एक साइड कोने वाला पानी पहला गिरता है, फिर ये बाद में, फिर बाद में? सब एक ही साथ गिरेगा ना. अगर सब एक ही साथ गिरा तो एक लॉजिक आता है, दिस हैज कवर्ड लेस डिस्टेंस, ऑब्वियसली इट शुड ट्रेवल स्लोली, है ना. और ये फास्ट कवर करके ज्यादा डिस्टेंस वही टाइम पे कवर करेगा, तो ऑलवेज टॉप वाला लेयर इन द पाइप इज फास्टर एज कंपेयर टू द बॉटम, लेकिन दो लेयर के बीच का डिफरेंस इज सेम तो स्ट्रीमलाइन हो जाता है, उसको बोलते हैं स्ट्रीमलाइन फ्लो। तो ये वेलोसिटी सपोज एकदम जो टच में है, ये ऐसी टिप 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 ड्रिप हो रहा है, इसका वेलोसिटी सपोज आई एम एज्यूमिंग 0, मतलब इधर से ड्रिप हो गया, एक एजम्पशन ले रहा हूं 0, इसका सपोज 5, इसका 10, इसका 15, तो दो लेयर के बीच में वेलोसिटी इज इंक्रीजिंग बाय सेम अमाउंट। हेलो,
Yes, sir.
so 5 becomes 10, 10 becomes 15, 15 becomes 20, so change is same, that is called dv। और ये लेयर के बीच का डिस्टेंस को बोलते हैं dx, बिकॉज यू आर टेकिंग हॉरिजॉन्टल डायरेक्शन और ऐसा परपेंडिकुलर, तो ये डिस्टेंस को मैंने परपेंडिकुलर टू द फ्लो ऐसे नाम दे दिया dx। d मतलब चेंज, आपको चाहिए तो dy भी बोल सकते हो।
Yes, sir.
तो रेट ऑफ change of velocity with respect to distance between two layer measured perpendicular to the flow, perpendicular to the flow is called as velocity gradient. It is dv by dx. What will be its unit? dv by dx का unit, dv means meter per second ना, velocity means meter per second no,
Yes, sir.
and dx is meter ना,
Yes, sir.
मीटर मीटर कैंसिल होके क्या बच गया, सेकेंड रेज टू
1 by second.
तो ये आपको मेजरमेंट चैप्टर में एक बार यूज हुआ था।
Yes, sir. Yes, sir.
Again I am repeating, what is velocity gradient? The rate of change of velocity to the distance between two layer measured perpendicular to the flow of liquid is called velocity gradient, given by formula dv by dx. SI unit second raised to -1. Again, shall I explain?
Sir, can you repeat the statement?
Once again, that I will make you right. Huh? Just again listen.
Okay, sir.
Again listen, don't worry. These are layers, okay? एक लेयर, दो लेयर, ऐसा layers. तो एक लेयर का डिस्टेंस इतना फ्रॉम बॉटम, दूसरे का इतना, तो दोनों के बीच का डिस्टेंस आई कॉल dx. ओके, दिस मच फॉलो? नॉट? dx means followed? dx means meaning of dx?
Yes, sir.
So from this surface, suppose this is 10 centimeter and this is 20. So what is dx? 20 minus 10, 10 or not? तो दो लेयर के बीच का थिकनेस मिला ना हम लोग को।
Yes,
तो
sir.
हाँ, वेरी गुड। सो द rate of change of velocity to the distance between two layers is called two layers measured perpendicular to the flow of liquid, or you can say fluid, is called as velocity gradient. Its SI unit is second raised to -1. So its dimension is m0, l0, t raised to -1. You all follow definition now? What is velocity gradient? Hello, any doubt is there in your mind?
No, sir.
Write down. It
No
is
doubt, sir.
right. It is defined as the rate of change of velocity with respect to rate of change of velocity with respect to distance between two layers measured perpendicular to the flow of fluid is called as velocity gradient. Is called as velocity gradient. Let dv be the change in velocity between two layers of thickness dx. Therefore, velocity gradient equals to dv by dx. Its SI unit is second raised to minus 1. Harshita, gravitation test paper you have not done,
Sir, I have done.
but you
You can
didn't
check.
send.
I sent it also. You said okay also.
No, gravitation when you send. 1 minute, I will just check because I was checking the paper, searching the paper, I didn't found. Magnet is this measurement you have sent.
Just before that only, sir. You can see.
I can see when you had gravitation test on Saturday, na?
Yes, sir.
I can see Sunday wala from other mobile you have sent.
No, no, sir. From my phone only.
See, what I received was of 11th Friday December. Then Sunday directly I received measurement. That I
So you gave test on Friday?
so Saturday I told na by Saturday you all submit the paper.
Yes, sir.
So I have not got Harshita. You please resend it.
Sir, I have. How
You have
can I?
not sent.
Sir, I
Might,
have sent it.
so might be you might have forgot to click because what
No,
I can
sir.
see
Sir,
Sunday
because
paper
I
is there.
remember you sent okay.
Okay, I have sent Sunday ka okay.
Yeah, that was for gravitation only, sir.
It might have gotten deleted from my side because okay I can also see. Okay, I have sent. Just resend if you have
Okay, okay, sir.
so that I can correct and give.
Yes, sir.
Okay. Nija, what about your paper?
I will send it, but I'll take time because my eyes are still paining.
Acha, so whenever you get the comfort zone, please send it.
Yes, sir, by this week, sure.
चलो सब लोग लिख लो.
Sir, I sent it
Just now,
right now. Can you see it?
1 minute. I have not yet received. So far, I have not received.
Yes, sir.
Just now I got now.
Yes,
Yes,
sir.
yes, yes. Okay. So, this much completed. Velocity gradient equal to dv by ds. Its SI unit is second raised to minus 1. Completed till last time. Its SI unit is second raised to minus 1.
Yes, sir.
This Sunday's test you are knowing, no? Which test you have? Which test this Sunday?
Sir, don't know.
I think I have told. Yes, Dhruv, can be you be louder? Amay?
Scalars vector and electricity.
Scalars vector and elasticity.
Yeah.
This is your test on this Sunday.
Okay, sir.
चलो right इसका आगे लिख दो. Its dimension is m0 l0 t minus 1. Shall I clear now this one?
Yes, sir.
Heading right. Explain equation of continuity. Explain equation of continuity. Suppose this is one tube through which liquid is having streamline flow. Streamline flow. If A1, V1 is area of cross section and velocity at entry, and A2, V2 is the area and velocity at exit, the flow will be streamlined if same amount of mass enters per second as the amount leaving per second. Like suppose I have a bag completely filled with small hole. I am pouring it in something, that same thing is coming out. तो ये हमेशा मुझे completely भरा हुआ दिखेगा ना, even if there is hole. बाउंसर क्या लगता है? I said I have a bag.
समझा sir.
समझा ना? यहाँ पे होल है, तो इसमें से पानी निकल के खाली हो जाना चाहिए ना?
Yes, sir.
At same rate मैं इसके अंदर भी पानी भर रहा हूँ, तो मुझे तो हमेशा भरा ही दिखेगा ना ये.
Yes,
Yes,
sir.
sir.
That means for streamline flow, the mass entering per unit time must be same as mass leaving per unit time. Then you will see that flow is streamline flow. One minute. I will derive one equation, but I want relation between area and velocity. Condition is mass entering must be same as mass leaving, then only flow will be streamline. नहीं तो कम ज्यादा हो जाएगा, zigzag हो जाएगा. So for streamline, you don't write anything. Huh? For streamline flow, the amount of mass of liquid entering must be same as mass of liquid leaving. Therefore, mass entering in unit time is equals to mass leaving in unit time. In unit time. Now please just draw the diagram, then I will clear to explain you much. Simple chapter है ये, 90% डायग्राम के ऊपर समझेगा. अनमोल शिरडी में गर्दी था?
Yes, sir. नहीं बहुत कम था, मतलब वो लोगों ने दर्शन अच्छे से कराया था.
अच्छा, मतलब people were nearly 20,000 or in lakhs?
No, they were much less actually, sir.
अच्छा. Don't write anything, just draw the diagram, write entry, leaving, A1, V1, A2.
Done, sir.
Okay. So if the flow has to be streamlined, then always amount of mass entering per unit time must be same as amount of mass leaving per unit time. Now mass entering per unit time means what? Mass per unit time at entry equals to mass per unit time at exit. What is mass? Can I say it is density into volume?
Yes, sir.
So density,
Yes, sir.
density of liquid at entry and volume at entry. Density will remain same. So I'm calling this as rho 1, m1 upon time. This is rho 2, v2 upon time. This v is not velocity, volume. Let v1 comma v2 be volume, capital V, at entry and exit. Now rho will be same because it is same liquid, है ना? But rho 1 is same as rho 2 for same liquid. So can I say this? I can cancel rho 1, rho 2.
Yes, sir.
ये वॉल्यूम है. वॉल्यूम मतलब क्या? Area of base into distance. Can I say that is volume?
Yes, sir.
Area. So at entry, area is A1. Let distance be D. 1 upon time T. At exit, A2. Distance D2 upon time T. What is distance upon time?
Velocity.
Yes. Therefore, A1
Yes.
V1 is called as A2 V2. This is equation of continuity. A1 V1, area into velocity at entry is same as area into velocity at exit. So equation of continuity is A1 V1 is A2 V2. Not followed?
Followed.
Chalo, likho.
Followed, sir.
Very good, very good. Please write down. I'm dictating now. Consider a pipe having varying cross section. Consider a pipe having varying cross section. Varying cross section. Through which liquid of density rho flows. Through which liquid of density rho flows. Let A1 comma V1. ऐसा small थोड़ा लिखो. Small V1. Let A1 comma V1 and A2 comma V2. Let A1 comma V1 and A2 comma V2 be the, let A1 comma V1 and A2 comma V2 be the velocities, be the area of cross section and velocity at entry and exit respectively. Be the area and velocity at entry and exit respectively. Then write for streamlined flow, the amount of mass of liquid entering must be same as mass of liquid leaving. Therefore, mass entering in unit time equals to mass leaving in unit time. then you can copy from screen. M upon T at entry equals to M upon T at exit. In DAV, they have started this chapter, mechanical property of fluid.
Yes, sir. They've finished this chapter and they started with waves.
Huh? They finished and started with wave also.
Yes.
तो क्या भाग रहे हैं वो लोग यार? Fluid तो बड़ा chapter है. How they completed so fast?
सर उनको 2 हफ्ता लगा पूरा कंप्लीट करने में.
अच्छा. और अभी waves पे आ गए वो लोग?
हाँ, अभी जस्ट स्टार्ट किया है.
ठीक है, हम लोग भी करेंगे. And in JK, which chapter is going on? Same chapter?
No, sir. They have started with simple harmonic motion.
That is wave. This they skipped or they have done?
They skipped this part.
Oh, so I should have started. Then they started with harmonic motion part directly.
Yes, sir, because they said that the simple harmonic motion part is important.
See, everything will be important. Simple harmonic motion is also important. Just started or they took many lecture?
In our class, they have just started.
अच्छा अच्छा ठीक है चलो हर एक का कॉलेज में अलग अलग चैप्टर स्टार्ट कर दिया. By end of year we will complete full chapters. Because for wave we require oscillation, that is oscillatory motion. After completing this chapter, then I will go to oscillation and then wave. Am I in your college still kinetic theory is going on?
No, so we did the perfect gases wala chapter and now we have our holidays now. So like
No new chapter started, na?
no.
Completed till A1 V1 equal to A2 V2.
Yes, sir.
This is known as equation of continuity. This is known as equation of continuity. Shall I rub this now?
Yes, sir.
Yes, sir.
State Newton's formula State Newton's formula for viscosity. See, whenever Newton comes, it is something related to the force. Now, if this is flow of liquid, that means there is somebody applying force from left towards right, correct? Then only this will move. है ना, कॉमन सेंस है, ऐसी फोर्स एक्ट होगा ना. क्या ऐसा फोर्स अप्लाई करो उसको मूव करने के लिए? हाउ शुड आई अप्लाई?
First one.
फर्स्ट वन. सो दिस इज टेंजेंशियल और परपेंडिकुलर.
Tangential.
ये सरफेस को टेंजेंशियल हो गया. सो न्यूटन described by different experiment and found that tangential force acting on any layer is directly proportional to area of that layer. And we also know if layer is very much broad, तो ज्यादा force लगेगा ना इसको move करने के लिए. So it is
Yes,
directly
sir.
proportional to area. It is directly proportional to velocity gradient also. Velocity gradient इसलिए अगर ये बीच में स्पीड का फर्क ज्यादा तो ज्यादा फोर्स आएगा, तो ज्यादा एक्सेलरेशन होएगा, ज्यादा चेंज इन वेलोसिटी होएगा. तो उसने अपना न्यूटन फर्स्ट लॉ सेकंड लॉ को ही एक्चुअली समझा के बोल दिया. सो अकॉर्डिंग टू न्यूटन, टेंजेंशियल फोर्स acting on any layer of liquid is directly proportional to area of that layer and proportional to velocity gradient between the layer. So I can conclude like this now. Force is proportional to area and proportional to velocity gradient dv by dx. F is some constant into a dv by dx, where this is called eta, where eta is a constant called as coefficient of viscosity, called as coefficient of viscosity. Now write, I'm dictating. According to Newton's formula for viscosity, the tangential force acting on any layer is directly proportional to, first one, area of layer in bracket A, area of layer in bracket write A. Second point, velocity gradient dv by dx, velocity gradient dv by dx. Therefore F proportional, copy now this much. Therefore F proportional a dv by dx
Done, sir.
where eta is called coefficient of viscosity. वहां तक हो गया?
Yes.
Okay. आज के लिए लास्ट टॉपिक, डिफाइन coefficient of viscosity and obtain its dimension. See, since f equals to eta a dv by dx, if area is 1 meter square, dv by dx is 1 per second, then can I say f becomes eta? Can we say like this? Then f becomes eta. If a equal to 1 meter square, dv by dx is 1 per second, then can I say f becomes eta? Can you hear me? Can I say like this?
Yes, sir.
Thus, coefficient of viscosity is defined as tangential force acting on layer of unit area of cross section having unit velocity gradient. Please write this definition, then I will find its SI unit, then dimension, then we'll stop. Coefficient of viscosity is defined as tangential force. Sometimes we can say viscous force, meaning is same. Acting on layer of liquid of cross section unit area of cross section having unit velocity gradient.
Done, sir.
फोर्स का यूनिट न्यूटन है ना, फोर्स का
Yes, sir.
ईटा का चाहिए हमको, एरिया इज मीटर स्क्वायर, dv by dx is per second. So when you cross multiply, it will become Newton second upon meter square. The force is Newton, eta I don't know, area is meter square, dv by dx is second raised to -1, that means 1 upon second. So cross multiply करूंगा तो what I will get? Newton second upon meter square. Hello?
Yes, sir.
Right. Its SI unit is, its SI unit is Newton second per meter square. So what will be its dimension from this unit? Its dimension is m1 L1 t minus 2 into t1 upon L2. Am correct?
Yes, sir.
Okay. That is its dimension equal to m1 L minus 1 t minus 1. Very important. Please you try to remember this. Coefficient of viscosity is m1 L minus 1 t minus 1.
Done, sir.
So that's all for today. 4 lectures will require to complete this chapter. Then if oscillation we start, नहीं तो इसका MCQ करके, so around 6 lecture I will take, but before exam सबका portion में कर दूंगा complete, आगे पीछे extra लेके.
Yes, sir.
अभी DAV वाले का तो exam point of view से we have completed exam वाला portion. We are in fact ahead, correct? Only when HF, हमें आपका आएगा तो just tell me which chapter they have. Extra,
Yes,
I will take extra lecture. Same way for JK student we can do. But right now I'm completing this chapter with MCQ. I will complete. Then I will start with this. So at least 6 lecture will be required. That means 2 weeks. And next week I think you will have holiday in the school, so we will be able to manage. This